Hello my dear EAPCET students, I welcome you to NEET World. So today we will be discussing exclusively EAPCET PYQs. So I have collected few questions from different chapters that are related to the EAPCET previous year papers. Okay, so if you are seriously looking for this EAPCET, you just subscribe our channel first so that you will get daily updates from us, and you can also use the content very effectively for your preparation. Okay, so definitely all the content which we are sharing from our side will be the best of best, that will be very useful for you. Okay, so just follow us, and you can also contact us for more information to join our courses or anything related to that. Okay, so that will be like if you are looking for mentorship and all, just contact to the mobile number which are given in the description box. Okay, yes. So look at here, the first question: which are the following substances shows the highest colligative properties? Okay, this is from solutions chapter. So how you can able to approach this question? Very easy now. So colligative properties, these are the special properties which are just depends upon number of particles in the given solution. So number of solute particles will decide the answers for this. So how can you say like more the number of particles, more the number of solute particles, more are the colligative properties. What are the examples for colligative properties? Like yeah, just give me a minute. Yeah, so what are the examples for colligative properties? Like elevation in boiling point, depression in freezing point, osmotic pressure, and RLVP, relative lowering of vapor pressure. These are the colligative properties, right? Yeah. So now how can you decide that? So just look at the given electrolytes. See, all of them are salts, right now. So this is NaCl, BaCl2 salt means. So we have one Ba plus 2 ion and 2 Cl minus ions right now. So total ions are 3. So like that you just identify number of ions. Here it is AgNO3, it means 2 are there, one anion, one cation, and urea is a non-electrolyte, it means it won't get dissociated in water. So the particles, number of particles will be 1 in the case of urea. Okay, so in the case of ammonium phosphate, okay, so here how many are there? So 3 ammonium ions are there, 3 cations and 1 phosphate anion. So total 4 ions are there. So where the more number of ions are there, so that will be having more colligative properties. So which will be having maximum here. So maximum number of colligative or highest number of colligative properties is for D. So for this question, option number D will be your answer. And if they ask us to arrange them decreasing or increasing order of colligative properties, so what is your answer? So first of all D, and after that here we have in option number A 3 ions are there, so it will be having more number of particles, more colligative properties. After this, here 2 ions are there, you take B here, and the least is C. So DA, BC will be your the order of highest to lowest number of colligative properties. Okay, hope this is clear. Yes, tell me what is the arrangement of colligative properties for this particular electrolytes. Here I am giving you first one is 0.1 molar NaCl and 0.1 molar CaCl2 and 0.1 molar, next what I can take here is sucrose, or just they will say sugar, okay, and 0.1 molar ethanol, ethanol, ethyl alcohol. So tell me, answer this question, arrange them from highest to lowest, highest to lowest colligative properties, highest to lowest colligative properties in the comment box. Okay, I will be looking into it. Just give me what is your answer. Just tell me your answer for this question in the comment box. Okay, so tell me which is having maximum number of colligative properties to minimum. Arrange this in the maximum to minimum. Okay, always remember colligative properties directly proportional to its Van 't Hoff factor, number of I, and inversely proportional to its molar mass of particles, I mean molar mass of solute particles. Okay, so based on this you can answer this. Okay, yeah. So just answer me this question in the comment box. So if you know, if you feel it is easy, so you can answer, you can express your answer in the comment box, right? Yeah, let us move forward. So look at here, we have a question from electrochemistry. So tell me, what is your answer for this question? From Cold-Rush law, see what is the molar conductivity of acetic acid at infinite dilution. So what is the molar conductivity of this acetic acid in infinite dilution? So tell me anyone. Yeah, so look at here, molar conductivity of weak electrolytes. See, acetic acid is a weak electrolyte now, so it has one acetate ion and one H plus ion. So these ions, one cation and one anion, that should be considered from the strong electrolytes, because weak electrolyte will not undergo complete dissociation. So by using the indirect method, that is using the strong electrolytes which are contributing these ions, we can able to find molar conductivity of a weak electrolyte like acetic acid. So I can take, for finding this, I can use barium acetate. So limiting molar conductivity of barium acetate, that first one BaOAC twice, okay, OAC twice, plus, see we have acetate ions here, 2 acetate ions, and we need H plus ion. So for one acetate we require one H plus ion. So here 2 acetate, so 2 molar conductance of HCl, limiting molar conductance of HCl, and you know here we have barium and chloride ions are extra, so remove that. So it means minus limiting molar conductance of BaCl2, that's it. Okay, so this will be giving how many acetate ions we are getting here? 2, and here also 2. So you are getting 2 del naught of ACOH. ACOH means acetic acid. Okay, like this. So now this is what you need to want here. So what I can take, the value for this BaOAC is given as x1. So take it as x1, plus for HCl they mention it as x3, so 2x3, because it is 2 times now, 2x3 I am writing, minus for BaCl2 it is x2, so remove minus x2. This is equals to 2 times of limiting molar conductance of acetic acid, like this. Okay, so I want limiting molar conductivity of acetic acid is equals to x1 minus x2 by 2 plus x3. So this will be your answer. So where do we have this kind of option? See, first option, option number A, x1 minus x2 by 2 plus x3 will be your answer. Yes, yeah, gamer, AG gamer, your answer is correct here. Yeah, I think it is clear now. There is no blur in the video right now. Yeah, please mention if any time you have found any blur in the video, I will correct it. Yeah, next question here we have is, so Van der Waals factor of ferric sulfate, assume 100% ionization. See, all the questions are the previous year paper, from the previous year exam of exam papers of EAPCET. Okay, so just tell me your answer. So can you tell me your answer for this question? Give me a try for this. Give me your answer for this question. So ferric, it means iron should be in +3 oxidation state right now. So Fe +3 should be there, and sulfate SO4 2 minus. So from this, use crisscross method and make the formula. So you will get Fe SO4, so minus 2 now, so here you can put 2 and here you can put 3. So overall molecule is neutral. So ferric sulfate, this is. So ferric sulfate, upon keeping in water, what happens? So it will dissociates like 2 Fe plus 3 ions and 3 sulfate ions right now, like this you are going to get. Okay, so now for this, what is the Van der Waals factor formula you have to use here? So dissociation is taking place now. So initially you have one ion at time t0, there is no dissociation. After some time, so these ions are dissociating now. So for this, what you have to use? Just use a formula, I equals to 1 plus n minus 1 alpha d. So alpha d means what? Degree of dissociation. How much they are saying? It is 100% dissociation. It means alpha d will be equals to 1. Okay, so I equals to 1 plus, how many ions are there here? So 3 plus 2, 5 minus 1. So 5 minus 1 into 1. So it will be 4 plus 1, 5. So total degree of dissociation or Van Haar factor will be 5 here. So simple, for a strong electrolyte, I is equals to number of particle, I equals to n. This is for what? Strong electrolytes. So how many ions are there here? 2 plus 3. Since it is strong electrolyte, so I is equals to n, that is equals to 5. Number of ions formed will be its Van Haar factor. Okay, yes. So based on this, you tell me yes. C, those who are answering C, yes, your answer is perfect. Yes. Yeah. So next, tell me for this, I have an electrolyte of this kind, A3B3. I have an electrolyte of A3B3 type. So what is the degree of dissociation? So I am mentioning degree of dissociation as alpha D is equals to 90%. 90%. So tell me what is its Van Haar factor? What is its I value? So anyone in the chat box? So what is the simple formula I have given there? I equals to 1 plus n minus 1 into alpha D, right now. So put this alpha D, degree of dissociation, how much I mentioned? 90%. So take alpha equals to 0.9 and n is equals to how much? I am saying this is a strong like consider it as a strong electrolyte here, like given 90% now, so put 90. So n value will be 3 plus 3, 6 minus 1. So just add them and multiply with 0.9 and add it to plus 1. That's it. That will be your I value, right? Yeah. Let me move forward with few more questions. The number of Faradays required to completely deposit magnesium from 1 liter to 0.1 molar magnesium chloride aqueous solution. So tell me, how can you do this? See, every time just remember this point. So to deposit magnesium, see any ion, so if it is in cationic form, magnesium here it is in +2 oxidation state now. So in order to deposit this as a magnesium atom, okay, so you require 2 electrons, okay. So for 1 mole of magnesium +2 ion, you require 2 moles of electrons, so that you will get 1 mole of magnesium chloride, okay. So just remember this point. To deposit 1 gram equivalent of any electrolyte, you required 1 Faraday of electric charge, okay. 1 Faraday means like 96,500 coulombs we are saying now, yeah, like that. It means number of moles into like Avogadro number of electrons, like that, okay. So here what you need to take is, here 2 electrons now, so number of gram equivalence is nothing but n into n factor. So what is the n factor of magnesium +2, right? +2 is converting into 0. So its n factor will be 2. Okay. How many moles they are saying? 0.1. Okay. 0.1 into 2. This gives how many Faradays here you need to check. That's it. Number of Faradays they are asking. So this will be how much? 0.2. So your answer should be for 1 GN you require 1 Faraday. So for 0.2 to GN you require 0.2 Faraday. That's it. Very simple now. Based on this simple relation, you can able to solve this question easily. So option A will be your answer, right? Okay. Next. Here, so tell me for this, if E0 cell of an equilibrium reaction, this is an equilibrium reaction they are saying, its E0 value is given like this, 0.59. The equilibrium constant Kc is how much? Equilibrium constant they are asking. So what is the relation between E0 and equilibrium constant first? This is what we need to know first. So look at here, from basic equation like E0 cell, from where we are getting this E0 cell, G0 is equals to minus NRT like NRT log NRT, see, I can write this now, G is equal, delta G equal to delta G0 plus nRT ln Q, right now. So at equilibrium this will be 0, delta G will be 0, then delta G0 will be equals to minus nRT log ln K equilibrium, right now. From this I can write this as minus NF E0 cell, which is equals to minus nRT ln K equilibrium, right. So from this I can remove this, okay, I can remove this. so that you are going to get a positive sign here. So here E naught cell equals to RT by NF into 2.303 log K equilibrium right now. So at 298 Kelvin, so I can write these values RT by NF as 0.059 by N. This is log K equilibrium, which is equals to E naught cell. E naught cell value mentioned as 0.59 right now. So from these we require this K equilibrium. See, I can directly give formulas, but I just want to derive everything so that you will remember the concept also right now. So even if you forgot the formulas, you just come from here, from thermodynamic relation between delta G naught and K equilibrium you can use for deriving all these things. So what is the final formula I have used here? So K equilibrium equals to E naught cell by 0.059 here into N, which is power of 10. That's it. This is what the formula I have derived from here. So here this will be 10 times into what is the N value they have given. So look at the reaction, how many electrons are participating. See, A converting into A plus 2. So N value is 2. So multiply this 2 into 10, which is equals to log K equilibrium. Okay. So from here 20, it means 10 to the power 20 will be your K equilibrium value. Okay. Like this also you can do, directly use this formula. K equilibrium equals to 10 to the power 0.059, E naught cell value mentioned as 0.59 into 2. So this will be 10 times. So 10 into 2, 20. So 10 power 20. That's it. So in both ways you are going to get same answer. So either use this direct formula or you can use complete derivation to derive this. Okay. So what is your answer for this? So 1 into 10 power 20. So option number D will be your perfect answer for this question. Right. Yeah. AG gamer, yes, it is D. Next. So this is from chemical kinetics. Anyone in the comment box can answer this chemical kinetics question. See, by looking at the data and initial rate, you need to find a rate constant of this reaction. So easy, right? So look at here. First of all, find what is the order of reaction. So why we need to find order of reaction? In order to find this rate constant. So we know rate is equals to K into concentration of A to the power M and concentration of B to the power N we are writing. So by knowing the orders with respect to A and order with respect to B, we can use this further data. So look at here, first of all find M and N value. See, when rate is increased like 2 times, see 2 into 10 power minus 2 becoming 4 into 10 power minus 2, it means rate increased 2 times. Okay, so when concentration of B is also increased 2 times and being concentration of A remains constant, no change in concentration of A, but concentration of B increased 2 times. Okay, so it is increasing 2 times, this is also increasing 2 times. So it means the order with respect to B will be 1, because when it is increased 2 times, this is also increasing 2 times now. So if the same number of times, if there is change in the concentration and rate, the order with respect to that particular component will be 1. So B to the power 1. Okay, order with respect to B is 1. Similarly, order with respect to A we need to find. So look at here, concentration of B to B is 0.04, here also 0.04, but concentration of A is increased 2 times and here rate is also increased 2 times. Here also I can say constant order with respect to A is also 1. So here also I am writing 1, which is equals to K into equals to R. Okay, so the total order of this reaction is second order. Okay, now you need to find K value here. So for this, use any of the data and substitute there, then you will get the answer. So I am using the first data. Rate value, how much they given? 2 into 10 power minus 2. Okay, put here. So K into what is A value here 0.02 and B is also 0.02. Like this you can take. Okay, so now K you want now, so K is equals to K into 4 into 10 power minus 4 I can write, which is equals to 2 into 10 power minus 2. So this will be 2 times and this will be 10 power minus 2 times. So K will be if I send them this side, so it will be 2 and here I am writing 100. So this answer will be 50. So what is the rate constant here? 50. So you have now option D will be your answer. Again right. Right. Is this clear? Right. Yeah. Let us move forward with few more questions. Yeah. Look at here. If the rate constant for a first order reaction is 2.303 into 10 power minus 3 second inverse, K is given. Find the time required to reduce 4 grams of reactant to 0.2 grams. Very easy. So what you need to do? So K they are asking. If rate constant they are given and they are asking time. So what is the relation? K is equals to rate constant K is equals 2.303 by T log A naught, initial concentration and concentration at time T, AT I am taking, right? Okay, I want this time. Okay, if you are new to this chemical kinetics, just watch my lectures on chemical kinetics where I have discussed everything here. Okay, so 2.303 by K, how much K mentioned? That is also 2.303 into 10 power minus 3 second inverse into log, what is initial concentration? It is 4 grams, take 4 grams, and what is the concentration at time T? So that is 0.2 grams. Okay, right. So I can remove this. So time is equals to 1000, I can write 1000 seconds into, this will be how many times? Grams, I can remove this 40 by 2 means 20 here. So log 20 I can write log 10 plus log 2 right now. So log 10 is 1 and log 2 is 0.3. So I can write 1.3 here. Okay, so this will be 1300 seconds. Okay, I got in seconds, the time I got in seconds, but all the options are in hours. So what you need to do? So if I divide this 1300 by 60, I am going to get minutes, and further again I divide with 60, I am going to get in hours right now. So 0 0 removed. So 13 by 36 I have. 13 by 36 I have. So if I put decimal, so 130 by 36 means around 3 times. So here you can just check the option number C, we have 0.36 hours we have. Yeah, so your option number 3 C will be perfect here, right? Yeah. So is that clear or not? Anyone in the chat box? Yeah, let us move forward with few more questions. Look at this, arrange the following in the increasing order of pKa values. So there are 4 options, you need to give the order of pKa. So how do you know pKa values here? No need of knowing pKa values, but you know the acidic nature na, based on the concept of mesomeric effect, inductive effect, you can able to solve this. See, we have nitro group and methoxy groups. What is the nature of those groups we need to find first? This electron withdrawing group, this electron releasing groups. Okay, given carboxylic acids are there and one phenol is there, always carboxylic acids are more acidic. First find the acidic nature order. So acidic nature order directly proportional to Ka, acid dissociation, and inversely proportional to pKa. Okay, so first find its acidic nature order, so reverse of it will be its pKa order, that's it. Okay, so acidic nature order, which is more acidic? Carboxylic acids are more acidic, but given in the given carboxylic acid, electron withdrawing group containing carboxylic acids are more acidic. This one is more acidic because this carboxylic acid is more acidic because it is having electron withdrawing group, because that electron withdrawing groups increases the stability of their carboxylate ion. Therefore, A is more acidic. First I am writing acidic nature order. So A is more acidic. After that, see here there is no group and here electron releasing group. Electron releasing groups decreases acidic nature. Okay, so here no either electron withdrawing, electron releasing. So I can write here D, and after that I can include B, and least is phenol here, C. Okay, this is the acidic nature order. If they ask for pKa, here they are asking for Ka, pKa. So what is your answer? Reverse of this. So C will be more, and after that B and D, and next is A, least is A. pK order is like this. So choose the option having like this. See, option number C, which is having more pKa, C, B, D, A. So option C will be your answer, right? Right. Okay, so for this question, option C will be your answer. So how we explain? This is based on the stability of conjugate base of this given carboxylic acids. Okay, so it is C, not D. Those someone in the options chart box saying D. No, it is C. Okay, Chennai. So why? Because it is more acidic now. Why? Electron withdrawing groups increases the acidic nature of carboxylic acids because of stability. Okay, why not D, you are asking? Why not D? See, they are saying in option number D, they are saying least acidic is D. No, carboxylic acids are more acidic than phenols. Always remember, carboxylic acids are more acidic than phenols. Okay, based on this you can give your answer. Yeah, look at this question again. So we have a compound here. This compound has to be treated with soda lime, so that we are going to get A, again followed by treating with zinc dust gives B. Okay, what is AB, and this side CD. So easy here, whenever you treat with soda lime, the carboxylic acid group will be eliminated. Okay, why? Because soda lime is what? Calcium oxide plus NaOH. Okay, this is a combination. Okay, whenever you treat this, first base will accept this proton, then next decarboxylation takes place, removal of CO2 gives phenol first. So what is your A here? This is phenol. Okay, this phenol upon treating with zinc dust, zinc converts into benzene, phenol converts into benzene, and zinc oxide is formed here. So our A is phenol and B is this one, benzene. Okay, next look at the option having these two options, phenol. So here phenol, all options are there, benzene. Okay, this is not the one. So first three we need to answer. So whenever you are treating phenol containing compound like OH group containing benzene with carboxylic acid group is there na? So this carboxylic acid will be removed out here, and we are going to get a tri-substituted phenol derivative, Br and Br. Do we have any options like this? Yeah, so here you have one option. Okay, so your option number C will be most correct here, and D, here if you observe, you are heating now at 200 to 230 degrees Celsius. So again decarboxylation takes place to give you like this, phenol. Okay, so your option here also you have phenol. So this will be your answer. Option B will be your answer for this. Okay, right. Let us move forward. So tell me, what about dipole moment here? So dipole moment, you should take it as a vector quantity depending upon what type of groups attached here. See, chlorine is there, electron negative group withdraws electron towards itself, and here also itself. So net dipole moment is cancel outing each other, mu will be 0 in this case. Okay, and in the other case, so here also dragging above side electronegative group, here also below side, so mu net will be 0 as they are cancelling out each other. So in case of 3, 4, we have OH groups now, these are not linear, they are non-linear groups right now. So you have one OH like this, another OH like this, so they won't cancel out each other here. Okay, so they won't cancel out each other like this we have. Okay, so it means net dipole moment not 0 in both of this case. SH also similar to OH, non-linear groups, like water molecule means you have like this now, bent shape now. So similar to this, just remove one hydrogen and replace with benzene ring. Okay, you are going to get the compounds like this. So they are non-zero in 3 and 4 and 0 in 1 and 2. So you can go with non-zero option as a C. Okay, as A, 3, 4 as your answer, right? Yeah, let us move forward with, yeah. So for in a chemical reaction, if a chemical reaction is known to be non-spontaneous at 298 Kelvin but spontaneous at 350 Kelvin, then which among the following conditions is true for the reaction? So tell me, it is non-spontaneous at 298 Kelvin, it means low temperature, and spontaneous at 350, high temperature. So what is the suitable condition? So in order to make this delta G negative, spontaneous at 350 degrees Celsius, what we need to make, 350 degree Kelvin, what we need to make? So delta G can be decided by two factors, delta H and T delta S here, okay. So in order to make spontaneous at high temperature, so what does it mean? So T has more dominating here, so T at a higher temperature reaction is becoming spontaneous, it means delta H by delta S, delta H by delta S should be less than T, then only reaction becomes spontaneous. So what is the value here? 350 now, so it means delta H is, so this value has to be greater here, okay. It means delta H is positive, delta H is positive and delta S is negative, okay. Negative becomes what? Positive here now, so this is not the one. So just understand how can you put this delta G as negative in order to make delta G negative. So delta H is negative and delta S is positive, this is always spontaneous, there is no like temperature limit here, at all temperature it is spontaneous. But next case if you see, this is positive, first case is positive, in order to make total overall process as negative, so second one has to be positive, okay. If it is positive, then overall this should be the negative right now, so this has to be, the second term has to be dominating, that means temperature has to be higher. So what is the suitable answer for this? Your option number 2 will be your suitable answer for this particular question, right? Yeah. So yeah, here no, this is positive they are mentioning now, so option number C will be your answer because delta G has to be negative, okay. Option number C will be your answer for this question, right? Yeah, let us move forward. So what are the favorable condition? Delta G always negative for a spontaneous process. In order to make delta G negative, you need to look for this delta H and T delta S, okay. So in order to make reaction spontaneous at all temperature, so this has to be negative. In order to make this negative, I can put this negative and already negative sign is there, T, and delta S as positive. The overall term will be what? Negative plus minus negative. It means overall always negative in the conditions when you have delta H as negative and delta S as positive. So these are the conditions which makes this reaction spontaneous at all temperatures and pressures, okay. Like this you need to understand the 4 conditions. See, entropy increases in which of the following process? In a given chemical reactions, if delta Ng is positive, then you can say entropy increases during the process, okay. So here solid is there, okay. Here you have gas, so number of gaseous products are more now, so it means this delta Ng is positive in first case. Here also 1, 2, number of gaseous product, so 2 minus 1, so it is 1, right? Positive value you got, delta Ng is greater than 0, means entropy increases here also. Liquid converting into solid, what happens? Disorderness decreases as in the solid particles are arranged or closely packed, so entropy decreases in this case. So 1 and 2 will be your answer, only 1 and 2, option number B will be your answer for this, okay. Next, so take these questions as your homework questions. So try these questions. If you are really facing to difficult to solve these questions, so watch my previous lives where I have discussed the remaining questions of this whichever I am showing here, okay. So just go to the like previous live session, just go to the playlist and first give a try. If you are really facing difficult, just watch my previous live on EAPCET, exclusive discussion on EAPCET, okay. Yeah, try these questions, okay. So thanks for watching. If you have any difficulties while solving, write me in the chat box, I am going to explain that. Thank you for watching.